We have Sandeep here, Sandeep Modhvadia, our Chief Product Officer for Wind River. So all yours, Sandeep.
Awesome. Thank you, everybody. The biggest challenge we face is people and the unpredictability of people. More specifically, the way the industry has trained people and evolved them. Over the last 20 years, as universities have cranked out software engineers, we've basically ended up throwing them into two separate places. On one side, they end up building cool consumer tech, most of which manifest as an app that lives on your phone. On the other side, we build a bunch of B2B commercial applications, most of which now live in the cloud. And so we started teaching our developers some very important lessons that frankly don't work in the world of mission critical. So what did Facebook teach people? They said, hey, we're going to move really, really fast, and we're going to break things, and we're going to iterate, and we're going to learn. And we encapsulated all of this on the notion of being agile. What does that mean? Agile was meant to be iterative. It wasn't meant to do things really, really quickly and break them. On the other side, we have the Bezos Manifesto, where 20 years ago, Jeff made a massive change to the organization. He basically said, everything you build should be externalizable, and everything needs to have an API. And by the way, if you're not going to do that, you're going to be fired, which allowed us to eventually build up AWS. And so you had another set of developers who are building things in the cloud with almost unlimited resources. So you think about these two things. 90% of your developers that are coming out of school, 90% of the people who are out there who are building and creating value are saying we don't have restrictions and we don't have any type of limitations because we have the entire cloud to power us. And we're going to move fast and we're going to break things. Those types of principles don't actually apply to where we have edge computing. Because typically, edge computing, if you think about this in the context of non-being consumer, so I don't mean your smart doorbell or your thermostat, but I think about this in real world where physical meets digital. We can't do either of those things. You can't really push out updates to a physical device 10 times a day like you might do in the cloud or down to an app. Just can't do that. You certainly don't have the unlimited power of the cloud. You have swap restrictions, right? You have space, you have weight, you have power. And all of these are things that have to be managed for when we build software. Now, from a Wind River perspective, this is kind of anathema to us. For us, what we think about is, okay, well, how do we make sure things don't fail? And as we start looking across all the different profiles of use cases out there, across all the different industries, each industry has learned how to do mission critical in slightly different ways. And we're at a point now where those patterns are starting to harmonize and those industries are learning from each other. Because all of these guys came from independent places. It's not as if, hey, there was one giant behemoth in the cloud that set the standard and then everybody else learned from it. So I'll give you a couple examples of where this has to play in the real world. So the first one there is a cockpit controller. If you've been on any commercial jet in the last 20 years, I can almost guarantee you that it was running Wind River software to keep it in the sky. Right? The lesson here is that one of the things that they do is they forced robust partitioning. They say when we want to split out our systems, we are not going to do this through a single mixed criticality OS. They turn around and say, actually, we want robust partitioning through a hypervisor or through complete isolation of hardware. And that's one of the ways that they build redundancy in their systems. Medical is another really interesting one. How do they not reboot their systems when an application needs to change? So as an example, we have a customer who builds ventilators. And we had an actual customer, I say customer, a patient of our customer, who was on life support for 3 years. Couldn't breathe, couldn't do anything. And they had to be put on this life support machine to keep them alive for a period of time while their body healed. That device was up and running for 3 years continuously and never failed once. Can you imagine, just think about things like event logs recycling. Right? You have a fixed amount of hardware on that device, a fixed amount of storage, and you're collecting event logs. And you think about that device not having to keel over, right? So as we think about how do you make sure something can run indefinitely, there are things that we're doing around just resource management to make sure that you don't get into those cycles where the system gets clogged up and fails because it's been running for so long, right? That's different to the Airbus scenario. We know that plane is going to land at some point. It cannot stay in the air indefinitely. Every single plane lands. And when it lands, we know that we can cycle those machines. In the healthcare world, you can't really do that because cycling that machine could mean that somebody dies. Let's take another example. I'm going to talk to you about throughput. We work with one of the largest telcos in the world. And recently, I live in Southern California, so this is kind of near and dear to my heart. When we had the fires recently, they had to make sure that 911 emergency calls, specifically in that area, did not get dropped. It's not just about connecting them, but it's about making sure they weren't dropped as well. And the reason behind that, obviously, is when you're calling emergency services and you're trying to, articulate where you are and where the problem is, a drop call, again, could mean life or death. And so some of the things we're learning from there is how do you isolate hardware from software? So what the telcos are saying is, hey, our base stations are really expensive and really clunky, and I need to save costs. And what I want to be able to do is disaggregate software from hardware. How do I create the right abstraction layer to be able to do this so that I can buy off-the-shelf hardware, put it in any single one of my base stations, but I know things will still run? Right? So again, it's another interesting lesson. As you kind of go through these, you're talking about, okay, robust partitioning, continuously running, disaggregation of hardware from software. Do these sound like themes that we hear about in auto? Right. They sound kind of familiar to what we heard before, right? The one that I think about specifically here in auto is just raw performance. Just think about response times and the ability to respond to an outside stimulus. As we start thinking more towards kind of those L3 type scenarios, one of the scenarios that somebody painted for me was imagine your car is going through a four-way stop. And as it's going through a four-way stop, it crosses in the most legitimate way. It does so legally, it does so ethically, it does so bound by the rules that, of the road. And as it's doing that, an 18-wheeler comes out of nowhere and is about to sideswipe you. Can your system react fast enough to either slam on the brakes? Can it respond fast enough to push down the accelerator? Can it override what may be a digital control of how much acceleration is available to that vehicle to be able to go even faster? Right? So as we think about some of these scenarios, performance is not just about the safety piece, but it's the performance piece that we're learning about as well. And the reason we say that, and that use case is interesting there, is some of our friends who build planes and other types of flying objects really care about microsecond precision. And then the last one, this is one that I really like. The last one is the Mars rover. I always love when we talk about OTA, because every now and again we get OTA wrong, right? So you think about your vehicle when your vehicle does OTA. Does anybody here ever want to do an OTA while the vehicle's running down the street? No. Where do you do your OTA? You do it at the service station, you do it in your garage, you do it somewhere where it's parked up, or it's scheduled, overnight, whatever. Nobody's going to do OTA while that thing's running. It's going to be parked up somewhere. But if you screw up the OTA, it involves a truck roll. What happens if you screw up the OTA and you brick the Mars rover? It's not as if you can send somebody back up there. You might have a 9-year window or a 5-year window before you'd physically be able to get somebody up there. So as we think about how do you do OTA in a safe and secure and recoverable way, and by the way, that's not even factoring in the latency and not even factoring the round trip, these are some of the things that we're learning. By the way, all of these are real scenarios. These aren't made-up scenarios. These are actual customers that we have using this stuff today.
Thank you, Sandeep. Round of applause for Sandeep, please.
Thank you.